Algebra 1, Chapter 6.2, Substitution Method. Now, before we start into the steps here and talk about that, yesterday we talked about graphing, solving by graphing, taking a system, graphing each line, looking for where they intersect to find a solution. Sometimes our graphs were done correctly, but yet they were still misleading because we're not really good at making great looking graphs. If we had graphene paper or if we had a computer, we probably would have better results. So today we're going to learn something called substitution method, and substitution method is the algebraic method, or one of them, and it always works. If it's done correctly, you will always find the solution. So I've got 5 steps here for using substitution to solve. And the first one is solve one of your equations for a variable. It does not matter if it's x or it's y, but I want to get one of those variables by itself. Sometimes, like in the example that's already provided on the bottom of the page there, is already done. Like this is y equals. This one's already solved for y. We're happy for that. It's done. Other times, I'm going to have to solve for y. Well, remember, what you do to one side, you have to do to the other. Now, once we have that established, then in step 2, you're going to substitute that expression, that thing, like here, 4x minus 6, into the other equation where y was. So if I solve for x, I'd put it in for what x was. So you have to take what you solved for in the first step and put it into the other equation. If you use the second equation, you have to put it into the first equation. If you use the first equation, you put it into the second. Do not place the problem back into itself. It'll give you some misleading information. Once you've substituted, you will end up having one equation with one variable. Because as of right now, if you look at these, there's x's and y's in both of these. But if I substitute in, I'll have one equation, one variable, and then I can solve it. So step 2, substitute in. Step 3 is solve for the remaining variable, the variable that is left. Step 4 says, hey, once I have found that variable, I'm going to go back to the part that I solved in step 1 to solve for the remaining variable that still is outstanding. And then step number 5, check your answer. You need to check if your answer, your x comma y point, works for both. Not just one equation, but both equations. If it works in both equations, you're going to be fine. So, let's put this to work. Example 1, solve the system by substitution. I'm also going to start off by saying, if it says solve the system by graphing, you make a graph. If it says solve the system by substitution, you use substitution. If it says use elimination, you're going to use elimination. That's something we're going to learn next week. If it doesn't say, if it just says solve the system, then it's fair game. You make the choice. You solve the system. So here we go. I have this system here, and it says step number 1, solve the equation for one variable. If I'm looking at here, it looks like y is already by itself. Y equals 4x minus 6. That means it's already been solved. Step 1 is done. Now, the biggest thing that we're going to have to worry about then is moving on to step 2, is what is y? Y happens to be 4x minus 6. And that 4x minus 6 in step 2 says place that in for y in the other equation. So when I do that, I'm going to have to use parentheses because there's a 3 in front of that y. So I'm going to change colors here. 5x I'm leaving alone, plus 3 times something, and that something is the 4x minus 6, should equal negative 1. And I can place that in there. 4x minus 6. At this point, do you see that there are only x's left? And that means I'm not changing 5x, it's by itself, but I am going to take 3 times 4x, which is 12x, and 3 times negative 6, which is negative 18, should equal negative 1. And now you just solve. Gather up like terms, solve for x. Notice that I have a 5x and a 12x on the same side. What's 5x plus 12x? 17x minus 18 equals negative 1. I'm showing every step, and I am working the problem one step at a time. I want to get my x's by itself, so get rid of what first? 18. To get rid of a minus 18, you will add 18. What's negative 1 plus 18? Equals 17. Nice. Divide both sides by 17. X is equal to 1. So we got half the problem done. The cool part is, in step 4, it said, using the found variable, I found x to be 1. Substitute it back into the solved expression, aka that guy right here. Y is equal to some x's, but I know what x is. So y equals 4 times 1 minus 6. 4 times 1? So y is equal to 4 minus 6, or y is equal to 4 minus 6? Negative 2. You're done. You're done after you write this as a point. What's the point? X comma y. Correct. And there is your answer. The only thing we did not do was check the problem. Again, to check the problem, you place 1 comma negative 2, x and y, in for x and y in both equations. So, negative 2 equals 4 times 1 minus 6. What's 4 times 1? Minus 2, or minus 6? Is negative 2. Is negative 2 equal negative 2? So negative 2 equal negative 2? Check. That one works. How about 5 times 1 plus 3 times negative 2 should equal negative 1? 5 times 1? 3 times negative 2? And does that equal negative 1? Check. That means 1, negative 2 is the answer, and we're happy. Okay, problem number 2. Same thing, but this one is going to have us find a variable that you're going to want to solve for. So, number 1, isolate and solve for a variable. Which variable and in which equation do you guys want to choose? Do the easy one. You're saying the top one? Solving the top one for what? X? Okay, so let's talk about this. If I want to solve for this particular x, number 1, get rid of 5y, right? So subtract 5y from both sides. But what would the next step be to get rid of the 4? Divide by 4. But when I divide one side by 4, I have to divide both sides by 4. Question. Is 5 divided by 4? Nicely. What about 11? So that's probably not the best choice. So then you're maybe, okay, let's solve for y instead. But to get y by itself, eventually, I'm going to have to divide by... So is 4 divisible by 5 nicely? No. How about 11? No. So those are actually might not be your best choices. Guys, what I'm going to do is I'm going to look for one that has the no coefficient. There it is. This y is already kind of by itself, isn't it? The only thing I would have to do is add 3x to both sides. So I can get y equals 3x minus 13. Would you guys agree with that? And now y is by itself. Now I used the second equation and I used y. That means I need to place it in the first equation for y. I need to take this and place it there. There are some things that will not change. 4x plus 5 times what y is equal to 11. But what's going to be in that parentheses? 3x minus 13. At this point, we can take the 5 and do what? Distribute. To do that, 4x gets left alone, but 5 times 3x is 15x. 5 times negative 13. We know it's going to be negative. What's 5 times 10? Because isn't 13 10 plus 3? What's 5 times 10? It's 50. 5 times 3. And what's 50 plus 15? It's 65. I use the distributive property to distribute. Equals 11. Hey, we got some common terms. What is 4x plus 15x? 19x minus 65 equals 11. To get x by itself, do what? Add 65 to both sides. 19x equals 76. Divide both sides by 19. What does x equal, guys? 4. Okay, so we have 4. X is 4. Now we have to go back and solve for y. I'm going to take that answer and put it into that equation. So y equals 3 times 4 minus 13. What's 3 times 4?
12.
So y is 12 minus 13, which is y equal to? Negative 1. The point is 4, negative 1. And for this problem, the last thing we should do is check the problem. So to check it, it's 4 times 4 plus 5 times negative 1, hopefully equals 11. What's 4 times 4? 16. 5 times negative 1? Minus 5. Does that equal 11? 11 equal 11? Check. Next equation. Y first, so negative 1 minus 3 times 4 should equal a negative 13. That's -1 minus 3 times 4? 3 times 4 is 12. Does that equal -13? Yes, it does. Check. We are done. We are correct. Now, I'm ending it today. There's more to this. Just like yesterday, there were 3 results. There's a solution, there's infinite many solutions, and no solution. Today, I only showed you how to find if there is a solution. Tomorrow, we're going to go into those other 2 situations. So, your homework, skip, there we go. On day 1 of 6.2 is page 351, 8 through 13. Have a great day.